To understand what we are seeing as we fly over this landscape, imagine what the land looked like 13,000 years ago. The glaciers had stagnated in place, glacial ice had just melted, and the land was raw and newly formed. Torrential rivers that flowed from the melting ice had carried a huge volume of mineral sediments, sand, silt, and clay, and deposited them in characteristic forms such as outwash plains, eskers, kettle holes, and glacial deposits called kames. The melting ice left mixed mineral sediments piled up in moraines or plastered as till on valley floors. Valleys we see today were once often dammed and held water in lakes of varying size and duration. Sediments were saturated in the flat valley bottoms and began to support wetland vegetation. The plant community could have started as a marsh with herbaceous plants, or a shrub swamp, or even a forested swamp. Over thousands of years, the cold, anoxic, saturated, acidic conditions retarded decomposition, and peat accumulated. The peatland probably went through several vegetational stages, as long-term climatic conditions varied. If the climate was dry, woody vegetation would dominate and woody peat would accumulate. If the climate was wet, herbaceous vegetation would dominate and sedge or sphagnum peat would accumulate. If there were inputs of mineral-rich and less acid waters, the speed of decomposition might increase and peat would disappear. If you were to dig or bore down through the peat mass, you would be able to identify these vegetational stages and layers that correspond to dominance of certain plant types. What does peat look like? Peat is an organic soil made from living things. Peat soils found in wetlands are called histosols, derived from the Latin word for tissue. Because of the wet, cold, anoxic, and acidic conditions in peatlands, decomposition is slowed to such a pace that the organic material accumulates. There are several types of peats, depending on the degree of decomposition. A fibrous histosol, derived from fiber, is a type of peat made up of plant fibers that are little decomposed, such that you can actually identify the plants and their parts. Another type of peat is called a saprous histosol. Saprous are very well decayed, usually dark brown to black, slippery, and devoid of any recognizable plant parts on the macro level. In between fibrous and saprous are humus histosols, which have a level of decomposition intermediate between the two. A fascinating aspect of peat is its ability to preserve organic material. Although macrofossils such as cones, needles, twigs, and seeds are often found in peat, the most decay-resistant materials are pollen grains. By studying them, scientists called palynologists can determine what species of plants were growing and depositing pollen in varying layers of the peat. Depending on the relative abundance of pollen of different species, you can begin to develop a picture of what the vegetation was like within the peatland and in the surrounding landscape. Further, if you can identify the date of the peat from which the pollen assemblage was taken, using carbon dating, you can describe the vegetational community changes over the thousands of years since melting of the glaciers. Other decay-resistant materials, such as arthropod exoskeletons, can also be found and dated in the peat, providing additional information regarding the surrounding landscape's natural communities. Of course, we've all heard about mastodons preserved in the peat of Siberia. They have been found here also. So-called bog people have been found in Scandinavian countries, deliberately buried in the peat and preserved in remarkably good condition. The large peatlands you see in this video show variations in their vegetation. Some parts are dominated by trees or shrubs. Some are dominated by sedges and other grass-like plants. Almost all are underlain by a layer of sphagnum moss of many different species. Differences in vegetation can be explained by the quantity and quality of the water falling on or running through the peatland. Generally, higher water levels preclude woody plant growth, and water with little nutrient value fosters the growth of sphagnum moss. Large open peatlands receive most of their water and nutrients from precipitation alone and are called bogs. Fens are another type of peatland that receive their water and nutrients from surface water runoff, like an open water body, or from upwelling of groundwater. Why is Spring Pond Bog called a bog when parts of it are a fen? Seldom does any wetland exhibit a single wetland cover type. Almost all are made up of a complex of wetland cover types. Names are often derived from generalizations. How will these large open peatlands change over time? Anything that affects the amount of water or its quality will have an effect on the peatland by altering decomposition and nutrient cycles. If the climate dries, the amount of water entering and residing in the peatland will be reduced. Oxygen will be introduced into the peat, and it will quickly begin to decompose, releasing carbon into the atmosphere and exacerbating the greenhouse gas problem. Decomposition rates will increase. The level of accumulation of organic matter will fall below decomposition rates, and the peat mass will erode. Is this different than what happened in the past? Probably not. The difference is that these changes are happening now in human time rather than geologic time. What took centuries to occur in the past is now happening in decades. Natural systems such as these large peatlands have evolved over 13,000 years, taking centuries to manifest changes. Now, those changes are happening over decades with highly disruptive results.